Okay, here we go. So, the first thing you have to do is you would have to read in uh, the data. So, you have this, I don't know what it was called, like slide dot dat, something like that. And so it's got a bunch of dashes for no bacteria, and then it's got, I think, asterisks for where there are bacteria. So let's just say, I don't know, there's one here, there's one here, 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 uh, here. Okay, so in this situation, um, after you've read in the data, I guess you want to read data into a 2D array. And reading from a file, that's something that we did last year, but you might have forgotten. So I think I do have a video. Let me just write down. I'm going to post that or repost it. I think I made a video last year for how to read into a 2D array for this one. So basically, you would want to read line by line, and the first thing in that slide.data is going to be two numbers, like the number of rows and number of columns. So you'll kind of be able to store those numbers and then size your array appropriately. So you read the data in. Then in the main method, you could, so in main, do a nested for loop through all like of the elements in the array. Okay, so you start doing that in your main. So you'll kind of start at, you'll say, okay, nothing there, nothing there, nothing there, nothing there, nothing there. Then you'll go to the second row and you'll go, okay, nothing there. And then all of a sudden you'll hit the bacteria. So, just a simple if statement, right? So once you've found a bacteria, then you can start the recursive algorithm, because from here, you want to do some checks, right? You want to check, okay, the colony is anything that's attached horizontally or vertically, but not diagonally. So it doesn't count if there's like an X down here. That's considered to be a different colony, this one. So yeah, just erase that one for now. Yeah. So we're gonna kick off the recursion here. So now, so step 3, I guess, would be, well, first thing you could do is, because you're supposed to say the location of the colony. So when you hit it in your nested for loop, as you're going through, you're going to say, okay, this is 0, 1, 0, 1. So this is actually in row 1, column 1. So you could print the location. Right, so it'd be, in this case, 1, 1. And then now you could start the recursion. So you could just say, recursive count of bacteria. Okay, so that's the part that's the focus of this unit. So so let's see, how are we going to do this? So there's going to be a few things involved. So when we hit one, we can count it right away. So in pseudocode, let's say we have this recursive algorithm called count. What does it need? Well, count would need two things. It would need an integer for the row and an int for the column. Right? That's just my handwriting's horrible because well, number one, I am not the best penman. My penmanship is a little bit lacking, but also the stylus is pretty bad. So anyways, so yeah, those are the two things that I need. So when I start in the first time, it would be a 1 for row and a 1 for column. That's what it is currently. Then I'm going to check. I mean, I know because the first time I know it's going to be a bacteria because that's why I started the recursion. But anyways, we should still check. So we could say if, well, first of all, I should probably check the base case. So if, so I'll just say row or call out of bounds. That means that, maybe if I had called it from somewhere like from here, up here, and then I try and go above it, it's because I need to check north, south, east, west, like from each spot. So if I go up from here, I'm going to be out of bounds. And when I try and check an array, element -1, that's going to crash. So I just want to make sure that the row numbers 0 or greater, and it also can't be off the bottom either. So you kind of have to check down at the bottom as well, and left and right, just to make sure none of them are out of bounds. And yeah, I should also check. Or it's not a bacteria. So if it's not a bacteria, or it's out of bounds, I want to just stop. I want to return 0. That's pretty much what we did for the other ones, right? And the else, is where we have to do a few things, right? We say it would be 1 plus, so 1 because we were on this one here. Yeah, so we were on this one here in yellow, so we'll count that one. And then we're going to go below and check there. And then we're going to go to the right and to the left, and we're going to go up. So we're going to check all those locations around it recursively. So we don't know what's there, we don't care right now. The recursive call will check for us, right? So we just say 1 because we know that's the one we're just on, plus a recursive call to our count at row. Okay, if we want to go up, it would be row -1. That'd be the one above. Same column, right? Plus count at row +1, comma column, right? And then etc. So you kind of get the point. You can add one to column and subtract one from column within the same row, and you'll get the left and right ones. And that's all good, right? So when it goes above to the one directly above it, it should, this one here is empty. So it should stop, right? When we call it from row 0, we should, like, when this thing here is a 1, a -1, and we do a 0, and the same column would be the one above it, and that one is empty. So when it gets there, recursion would stop and return 0, so that one ends. When I go down, same thing would happen there and there. But when I go down to this one below it, it's not empty. So it's going to say, okay, we got 1 here, and then a recursive call happening here. That from there, again, we're going to go left, right, up, down kind of thing. And we don't know what comes back from that because it's going to recursively call there and all the way around. And yeah, but once it hits the end, this last one here, there's nothing around it up, left or right. The only problem is, as you can think, there is one problem. I don't know, can you guys think of what the problem is here? Because I should end when I get to the end here. When I look up, it'll end, left and right, it'll end, but what is the problem with this? I have one bug in here. Yeah, there's no, I didn't really draw any more colonies, but I'm just thinking of, like, when it gets to the end, and even before it gets to the end, even on the one recursive call that I do below after the first step, like when it gets to this one here, it's going to recursively call left and right. There's empty below. Okay, there's 1, and then above, right? So does anybody see what the problem is?
Like going back down because we didn't set the bacteria to not bacteria. Like we didn't say that they visited previous bacteria.
Right. So it's going to be stuck in a loop, right? Because it's gonna go down. That's fine. It should recursively call down. But when it goes up, if we don't switch this one to visited, like somehow stop it, it'll call it from there again, and it'll like call from this one upright. So it'll keep counting the same ones that we already counted. So once we visit somewhere, we have to switch it so that we don't visit it ever again, right? Yeah, so you can make another array to track all that, or you could potentially, you could just switch it, right? You could just, you could just erase it. Okay, it's gone, right? So then, when I get to this one here and I look up, there's nothing there, it's empty. So it won't recursively call from there. It'll only see the one below it and go, okay, oops, I'm going to call it from here, right? Because there is a bacteria there. So yeah, so that's the thing that I didn't write in my algorithm, but yeah, you could figure that out. That's the easiest way, is just to get rid of it. I think that's pretty much everything for this one. So it's actually quite short when you look at it. It's really, again, recursion ends up with some pretty elegant short solutions. There's a few housekeeping things to do, like switching things to blank that should be in there, but I think that's basically it. So by the end, it should have a count, and it should return the count to back to the main method where it started calling these. So you could print whatever comes back from your count bracket, row and column, and it should eventually, after recursion's all done, it'll like go through, it'll add them all up, and it'll stop, and then it'll return the number to where you called it from in the beginning, from the main method, from 1, 1 up here. Now, that means that once it returns from the recursion and prints it, we're still in the nested for loop, which is good, right? So we just left off, checking. So we just checked that one, and now we finished, we got a number, and then we're gonna start checking here, checking here, checking here, checking here. Now this one says there's one there, but it's actually should have been erased from our recursion. So in fact, there's not one there anymore. And there's none of these exist anymore, right? So it can just go until it encounters something new that it hasn't found. So that's basically it. So, if there was another colony, down here or something, it would just keep checking, 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 checking. Doesn't find anything, until it gets to here, and then it goes, oh, there's one. So start the recursion again, and maybe there's one beside, and yeah, it can count that as another colony separately. So it won't double count the colonies because we've sort of switched them all to visited. Yeah, sorry, Emery. Well, I'll get back to grade 11 in a second. Yeah, we had to flip to the online, unfortunately. So hopefully I guess you got a bit of a walk going to school. My apologies for that. Yeah, so does that make sense, grade 12s? Any questions with that?
It made sense. Thanks. Post the
Yeah, at a
video
high
on
level,
dealing with the
it
file.
kind of makes sense. Yeah, I will post the file reading video, and I will I'll stop recording this, and then I can post that as well.